Let's talk about formation of ions. Now I'm going to start with a brief reminder that atoms are electrically neutral. What does this mean? In an atom, you have three particles: protons, neutrons, and electrons. Neutrons are neutral, so we're not going to take into account when discussing this. We are going to focus on the protons and electrons. Protons are positively charged. Electrons are negatively charged. Now, in any atom, and I mean any atom of any element, the number of protons is always going to be equal to the number of electrons. So if you have an element that has 15 protons, it's going to have 15 electrons. So if we have a positive charge of 15 as a result of the protons and a negative charge of 15 as a result of the electrons, what is our overall charge going to be? 0. So that is the reason why atoms are referred to as electrically neutral. Now, most atoms are unstable. So for them to gain stability, they either need to lose or gain electrons in order to have full energy levels. Octet configuration. Now, when an atom either gains or loses electrons, it forms a charged particle that is known as an ion. Now, ions can either be positively charged or negatively charged, depending on whether an electron was lost or gained. Okay, let's take an example of a metal, sodium. This happens to be one of my favorite. Okay, so sodium has 11 protons, atomic number is 11, and of course 11 electrons. So the atom itself is going to be neutral. Now, if you were to arrange the electrons of sodium according to their respective energy levels, you end up having a configuration of 281. So the sodium atom is not stable because it has one valence electron when it's supposed to have full energy levels of 8. Now, for it to become stable, it needs to lose its valence electron and therefore becoming 28. So when it loses its single electron, the number of electrons decreases from 11 to 10. What about the number of protons? They remain the same. In chemical reactions, the number of protons are never affected. So you're going to end up having a positive charge of 11 and a negative charge of 10. What is your overall charge going to be? Plus 1. So the sodium ion is positively charged. It has a charge of 1, and this is how it's illustrated. Now the equation that is used to represent this is as such. So sodium atom loses an electron to form a sodium ion. When you see an electron on this side of the arrow, it means that that electron has been lost. Don't let the plus sign fool you. Okay, now let's do another example of magnesium. So magnesium has the electron configuration of 282. For it to become stable, it needs to lose 2 of its valence electrons, and that is what happens. So the magnesium ion is going to have a charge of plus 2. Why? Initially, in the magnesium atom, you had 12 protons and 12 electrons. But when 2 electrons were lost, the number of electrons decreased from 12 to 10. So if you were to take this, you're going to end up having a positive charge of 12 and a negative charge of 10. So an overall charge of plus 2. So this information can be illustrated as such. Now I want to say this. The removal of an electron from an atom is what is known as ionization. So this always requires an input of energy. For you to remove an electron from an atom, you need energy to forcefully pull that electron away. Why? Because in an atom, you're going to have a positive nucleus because of the protons and negatively charged electrons. When you have oppositely charged particles, what do you have? You're going to have an attraction. So you're going to have a strong sense of attraction between the electrons and the protons. So if you want to remove that electron, you need to have energy to actually pull it out. This energy is what is referred to as ionization energy. Now, in the case of sodium only requires energy to remove its first electron. It only has one valence electron. As such, it only has the first ionization energy. Now coming to magnesium has 2 valence electrons, so it needs to lose 2. Now this does not happen at the same time. It's going to lose 1 valence electron and then lose the second one after that. So when it loses the first valence electron, that is referred to as the first ionization energy. The energy required to pull that first valence electron from the magnesium atom. Now, after that is done, you're going to need another input of energy for the last valence electron. This is going to be the second ionization energy. Now, I want to say this. The second ionization energy is always more than the first ionization energy. Let's look at magnesium. So this is the magnesium atom. This is the magnesium ion after it lost its first valence electron. So as you can see, you're going to have 12 protons and 11 electrons. Now the force of attraction that is going to be present here between the protons and electrons is going to be much stronger than it was in the atom, because you're going to have more protons than electrons. So for you to remove that second valence electron, Murife, you're going to need more energy than you required originally. So the second ionization energy is going to be more than the first ionization energy. What about aluminium? Aluminium has 3 valence electrons. So if it has 3 valence electrons, you're going to need the first ionization energy to remove first valence electron, the second ionization energy for the second valence electron, and then the third ionization energy for the last valence electron. Now, let me ask you this. Out of these 3, which do you think is going to be the highest? The last, the third ionization energy, because every time you remove a valence electron, you're essentially increasing the nuclear force of attraction, making it more difficult for you to remove another valence electron. More difficult means more energy you require. Now, what about if you have an element that has 4 valence electrons? Now, a lot of energy is required to remove more than 3 electrons from an atom. For this reason, you're going to find that elements in group 4 and onwards, 5 and such, they hardly ever lose electrons to form positive ions, because the energy that is required is too much. So they either gain or share electrons. Oh, I forgot something very important. The positively charged ions that are formed when an atom loses electrons are known as cation. Now moving on to negative ions. Now when it comes to nonmetals find it easier to gain electrons rather than lose. Let me take an example of chlorine. So chlorine has the atomic number of 17. 17 protons equals 17 electrons. If you arrange this in their respective energy levels, you get 287. So chlorine needs 1 more electron in order to have a full energy level. And that is what happens. Chlorine gains an electron when chemical reaction takes place. Now chlorine atom is this. Okay, so this is neutral. When it gains an electron, the number of electrons increases from 17 to 18. The number of protons, of course, remains the same. So you end up having a positive charge of 17, but a negative charge of 18. So an overall charge of -1. And this is the reason why the chloride ion is as such with this charge. So this information is represented as such. Now whenever you see an electron on this side of the arrow, this actually represents gaining of an electron. Now when an electron is gained by an atom, there is energy that is released. This energy is referred to as electron affinity. So this is energy that is released when an atom gains an electron in order to form a negatively charged ion. The ion is referred to as an anion.